Ask 10 engineers what CQRS is, and most will describe something enormous: a separate RID database, a message bus, event sourcing, projections, eventual consistency, the whole distributed systems circus. And then they conclude, reasonably, that it is too complicated for their project, and they are right to avoid that thing. But that thing is not CQRS. It is one very heavy way of doing CQRS, and it has been so thoroughly conflated with the idea itself that the idea has a reputation it does not deserve. Here is CQRS, the whole of it, in one sentence. The model you use to change your data does not have to be the same model you use to read it. That is the entire concept. Command query responsibility segregation. Separate the writes from the reads. It can be two classes in the same service against the same database that you could ship this afternoon. Or it can be the full distributed machine. Those are the same principle at wildly different price points, and the single most expensive mistake people make is assuming CQRS means the expensive one. 9 concepts. We will separate the idea from its most elaborate implementation. Be honest about the tax the heady version charges, and, as always, spend real time on when you genuinely do not need it, because that is most of the time. Start with the thing CQRS is reacting against, because the pain is real even if the cure is often overkill. In a normal application, you have one model, say an order class, and it does everything. It validates a new order, it enforces business rules, it saves, and it is also what you serialize to JSON when someone loads the order history screen. For a while, this is wonderful. One model, one place, easy. Then the two jobs start pulling in opposite directions. The right side wants a rich, carefully guarded object, invariance, validation, a small precise surface so nobody can put the order into an illegal state. The read side wants something completely different. It wants a wide, flat, denormalized shape that joins the order, the customer, the line items, the shipping status, and the payment state into exactly what the screen shows, fast, with no logic at all. Force both needs through one model and you get the familiar mess: an entity dragging 12 eager loaded relationships to render a list, a query object that has somehow grown business methods, a class nobody wants to touch because it serves 6 masters, and the killer asymmetry underneath it all. Most systems read vastly more than they write. Often 100 or 1,000 reads per write. You are optimizing the same model for 2 workloads that are not just different, but lopsided. CQRS says, stop. These are 2 responsibilities. Give them 2 models. Everything else in this episode is about how far you take that, and the answer is usually not as far as you think. Concept 1. The whole thing, before anyone makes it complicated. Here is the principle stripped to the bone. You split your operations into 2 kinds. Commands change state and return nothing meaningful, place order, cancel order, update address. Queries return state and change nothing, get order, list orders, search. This is actually an old idea called command query separation from Bertrand Meyer, and it was originally about individual methods. A method should either do something or answer something. Never both. Asking a question should not change the answer. CQRS takes that principle and raises it from the method level to the model level. Not just separate methods, but separate models. A write model whose only job is to validate and apply changes correctly, and a read model whose only job is to answer queries fast. And the crucial thing to hold onto, the thing the tutorials bury under diagrams of message buses. None of this says anything about databases. Nothing here requires a second data store, or events, or asynchrony, or eventual consistency. You can implement this entire idea as 2 sets of classes in one service reading and writing one database. The separation is about responsibility, which is literally the middle word of the acronym, not about infrastructure. Get that straight and the rest of the topic stops being intimidating and starts being a series of choices about how much machinery you want to bolt on, most of which you will decline. Concept 2. Same principle, 2 radically different price tags. CQRS is not a yes or no. It is a dial, and there are 2 settings worth naming. The lightweight version, 1 database, separate code paths. Your commands go through rich domain objects that enforce every rule. Your queries bypass all of that and hit the database directly. Raw SQL, a thin read-only view, a projection into a flat DTO. Because a query does not need your aggregate, it needs 3 columns and a join. Same database, same transaction, same consistency you already had. 0 new infrastructure. This is where the overwhelming majority of teams should live, and it captures most of the benefit. Your write model gets simple and safe, your read model gets fast and flat, and nobody had to learn a message broker. The heavyweight version, a separate read store, kept up to date asynchronously. Writes go to the right database. A process propagates those changes into one or more read stores, a denormalized Postgres table, an Elasticsearch index, a Redis cache, a graph database, each shaped for a specific query pattern. Now reads and writes scale independently. You can have 5 red replicas of different shapes, and you have also signed up for eventual consistency, a propagation mechanism, and a whole class of new failure modes. Both are CQRS. The difference between them is not the principle, it is the operational bill. And here's the mistake, stated plainly. People picture the heavyweight version, feel the weight, and reject CQRS entirely, when the lightweight version was sitting right there, free, solving 80% of their problem. Concept 3. Command, the guarded half. The right side is where correctness lives, so it is allowed to be strict and a little slow. A command is an intent to change something, a named thing, cancel order, with the order ID and a reason. Notice it is imperative and specific. It is not update order this blob, it is a business action with a name, and that naming is half the value. Because cancel order can carry rules that a generic update never could. A command handler loads the write model, the aggregate, in domain-driven terms, checks every invariant, applies the change, and persists it. This model is deliberately not optimized for reading. It is optimized for making illegal states impossible. You cannot cancel an already shipped order. You cannot set a negative quantity. You cannot skip a required step, because the model refuses. It is small, it is rich, it guards a consistency boundary. 2 things worth internalizing. First, commands can be rejected, and that is a feature. Validation, business rules, concurrency conflicts all live here on the right path, where being careful is cheap relative to the cost of corrupt data. Second, keep the command model lean. A frequent failure is letting red concerns leak back in. Someone adds fields to the aggregate just so a screen can display them, and now your guarded write model is bloated with presentation junk it does not need and cannot safely enforce. The write model answers exactly one question: is this change legal? And if so, apply it. Anything about how the data gets displayed is not its job, and that is the entire point of having split it off. Concept 4. Queries, the fast, dumb half. The read side gets to be shameless. A query returns data and enforces nothing, so the read model has exactly one goal: serve the screen as fast as possible, in the shape the screen wants. And that means you build read models per use case, not per entity. This is the mental shift people find hardest. You do not have a customer read model. You have an order history page model, and a customer dashboard model, and a search results model, each a flat, denormalized, pre-joined structure that maps one-to-one to a view. So the query is a single fast select with no joins at request time and no logic. In the heavyweight version, these are projections, materialized, kept warm copies derived from the right side, living in whatever store answers that query best. Elasticsearch for search, a denormalized table for the dashboard, Redis for the hot path. And here is the liberating part, the thing that makes CQRS click once you feel it. Red models are disposable. They contain no source of truth. The truth is on the right side. That disposability is a genuine architectural superpower. But do not lose the thread. In the lightweight version, your read model is just a good select and a DTO. Same principle, 1/100th of the ceremony, and for most screens that is completely enough. Concept 5. The conflation that ruins the conversation. This is the single most important clarification in the whole topic, and getting it right in an interview instantly separates you. CQRS and event sourcing are different things. They are constantly taught together, so people assume you cannot have one without the other. You can have either alone. CQRS, as we have said, is just separate the read model from the write model. Event sourcing is a completely independent decision about how you store your write data. Normally you store current state. Your order row says status equals shipped, and when it changes, you overwrite it. The previous value is gone. Event sourcing instead stores the sequence of events that happen: order placed, item added, payment received, order shipped, as an append-only log, and you derive current state by replaying them. That is a powerful and heavy choice with its own payoff, a perfect audit trail, and its own serious costs. Versioning events as your schema evolves, replaying long histories. The fact that you can never simply delete a fact. Now, why are they married? Because they compose beautifully. If your right side already emits a stream of events, those events are the obvious thing to feed your read model projections. Event sourcing produces a natural fire hose that CQRS read side loves to consume. So they are found together for a real reason. But, and this is the sentence to say out loud, you can do lightweight CQRS with plain state storage and no events whatsoever, and you can do event sourcing behind a single unified model with no CQRS at all. Conflating them is how people talk themselves into adopting two of the hardest patterns in the field to solve a problem that needed neither. Concept 6. What the heavyweight version actually costs. The moment your read store is separate and updated asynchronously, you have bought eventual consistency, and you need to understand the bill before you sign. Here's the failure, and it is the exact same one from ERDS episode wearing a new hat. A user submits a command, rename my account. The write succeeds. The screen refreshes, reads from the projection, and the projection has not been updated yet, so the user sees the OLD name right after changing it and concludes your app is broken. That is read your own rights, and in CQRS it is not an edge case you might hit. It is the default behavior of the architecture structurally guaranteed by the gap between write and projection. The lag is usually milliseconds, but under load, or if the projection process falls behind or dies, it can stretch, and now the whole system is serving stale reads and nothing is on fire. So you engineer around it, and none of the fixes are free. You can return the new value directly from the command so the UI updates optimistically without reading the projection. You can have the client pull or subscribe until the projection catches up. You can, for the specific screens that cannot tolerate staleness, read from the right side instead, deliberately breaking the pattern where correctness demands it. And you must monitor projection lag and alarm on it, because a wedged projection is an outage that looks like health. The point is not that eventual consistency is bad. It is that it is a genuine, permanent cost you take on with the heavyweight version, and it is precisely the cost the lightweight version, sharing one consistent database, does not pay at all, which is most of why the lightweight version is the right default. Concept 7. The cases that actually justify the weight. So when a CQRS, and especially the heavyweight version, genuinely the right call, the pattern to look for is asymmetry and specific, nameable asymmetry. First, a large read-write imbalance where the two sides need to scale independently. A product catalog read millions of times an hour and written to a few times a day. Putting 5 read replicas behind that while the right side stays small is exactly what the separate store version is for. Second, genuinely different read shapes. When one write model has to feed a full-text search, a real-time dashboard, and a reporting warehouse, no single schema serves all three, and separate purpose-built projections stop being overkill and start being the only sane option. Third, complex domains with real invariance on the right side but simple, high-volume reads. The classic case where a rich-guarded aggregate and a flat fast read model genuinely want to be different objects. Fourth, collaborative domains where many users hit the same data and you have concurrency to manage on the right path. The right model becomes the place that arbitrates conflicts, and event sourcing enters when you have a hard audit or temporal requirement. Fine. And healthcare, anything where you must prove what the state was at a past moment or replay history. Notice the shape of every one of these. They are concrete problems you can name and point at, not I read a blog post. If you cannot finish the sentence, we need CQRS because with a specific, measured pain, you have your answer, and it is no. Concept 8. How it goes wrong, and it goes wrong a lot. Now the honest warning, because CQRS is one of the most over-applied patterns in the field and the wreckage is everywhere. Do not reach for the heavyweight version for simple CRUD. If your reads and writes use basically the same shape, if your scale is modest, if a single well-indexed table serves both fine, then splitting into two models, two stores, and an async projection buys you nothing and costs you everything. Two models to keep in sync, eventual consistency bugs you now have to design around, a projection pipeline to run and monitor, and a codebase where the simplest change touches 3 places instead of 1. You have solved a scaling problem you did not have, and manufactured a consistency problem you did not need. The most common shape of this mistake, a team reads about CQRS with event sourcing, applies both to a straightforward booking system, and 18 months later they cannot onboard a new engineer in under a month and every feature ships slowly, because everything is an event and nothing is a simple update. The rule I would hand you, and it is the same rule as Quartz and Spring Cloud, start with the simplest thing that works, one model. One database, plain CRUD. Move to lightweight CQRS, separate read and write paths in the same database. The day a screen's query genuinely fights your write model, and that is a cheap, reversible step. Reach for the heavyweight, separate store version only when you have a specific scaling or shape problem you can measure. CQRS is a response to real pain. If you adopt it before you feel the pain, you have simply chosen a different, worse pain and paid for the privilege. Concept 9. What they are actually testing. When an interviewer raises CQRS, they are testing one thing above all. Whether you understand it as a spectrum of trade-offs, or whether you have memorized a buzzword and a diagram. So lead with the definition that proves the former. CQRS means separating the read model from the write model, and immediately add the correction that most candidates never make. It does not require a second database, and it is not the same thing as event sourcing. Saying those two things in the first 15 seconds tells the interviewer you have actually thought about this rather than watched one conference talk. Then show you know the dial. The lightweight version is separate read and write paths against one database, nearly free, and where most teams should stop. The heavyweight version adds a separate read store and buys independent scaling at the cost of eventual consistency. Then volunteer the tax, unprompted, because volunteering the downside is what senior engineers do. The moment the read store is asynchronous, read your own writes becomes the default, and here is how I would handle it. Return the value from the command, or read from the right side for the screens that cannot tolerate lag. Then, if they push on event sourcing, keep them cleanly separated. Two independent decisions that happen to compose well, not a package deal, and close on judgment, which is the thing they are really short of. I would not start here. I would start with plain CRUD and move to CQRS the day I could name the specific pain. A read that fights the right model, or two workloads that must scale apart. Anyone can draw the diagram, knowing that you usually should not, and being able to say exactly when you should. It is the answer that gets you the offer. Let us bring it home. CQRS is one idea. The model you use to change data does not have to be the model you use to read. Everything else is a choice about how much machinery to add. The lightweight version, separate read and write paths against one database, is nearly free, keeps the consistency you already have, and is where most teams should live. The heavyweight version, a separate, asynchronously updated read store, buys you independent scaling and purpose-built read shapes and charges you eventual consistency in return, which means read your own writes is now your default and you engineer around it deliberately. Commands guard the truth and are allowed to reject. Read models are disposable, built per screen, and rebuildable from the right side. CQRS is not event sourcing, two independent decisions that merely compose well, and conflating them is how people adopt two hard patterns to solve a problem that needed neither. Use it when you can name the asymmetry, independent scaling, genuinely different read shapes, complex writes with simple reads. And do not use it, especially not the heavy version, for simple CRUD at modest scale, because then it is pure cost. Start simple. Move when it hurts. Name the pain before you buy the cure. That is the whole discipline, and it is worth more than any diagram. Subscribe.